In this video, I'll explain one more application of first order linear differential equations. That is to know rate of growth or rate of decay. If the rate of change of a quantity u is directly proportional to the quantity present at any instant of time t, that is, rate of change of a quantity is denoted as du by dt. If it is proportional to the quantity present at any instant of time t, quantity present at any instant of time t is denoted as u, then this gives you a first order linear differential equation. When you write the constant of proportionality, you will get du by dt is equal to k into u, where k is constant, which is called as constant of proportionality. Now, if this k is positive, then this problem becomes it is a problem of growth. If k is negative, then this problem is called as problem of decay. So in any of the cases, this equation refers to first order linear differential equation because du by dt equal to k into u. You have to solve this first order linear differential equation to obtain the solution. So, the differential equation associated with the rate of growth or rate of decay is du by dt equal to k into du by dt equal to k into u. So to get its solution, you have to apply the method of separation of variables. So du by u equal to k into dt. Then integrating on both sides will get log of u equal to k into integral of 1 with respect to t is t plus I'll apply log of c, the constant of integration as log c. Then this gives log u minus log c equal to kt. Then log of u by c equal to kt. Now I want the value of u. So take exponential on both sides because this is natural logarithm. So I will get u by c equal to e to the power kt. So u equal to c into e to the power kt. So this is the solution of the differential equation du by dt equal to k into u. If k is positive, the problem is of growth. Therefore, in that case, you will get u equal to c into e power kt as its a solution. If k is negative, then du by dt equal to minus k into u. This problem is of decay. So in that case, the solution is u equal to c into e to the power minus kt. So you can directly remember the solution of this kind of growth or decay problem as u equal to c into e power kt for growth and u equal to c into e power minus kt for the decay problems. Let us solve one problem. See, here is a problem. The law for the decay of radioactive material states that the rate of decay is proportional to the amount of material present. Let U be the amount of material, U be the amount of material at any time t. At any time t. So then as per the law, the rate of decay, so du by dt is equal to, it is decay, therefore minus k into u. So du by dt is proportional to u, amount of material present. So the constant of proportionality is k with a negative sign because it is decay. And we have seen that its solution is u equal to c into e to the power minus kt. Now we have to get the values of these constants c and k using the conditions. If 30% of the material disappears in 10 days, this is given. So here given 30% of the material disappears in 10 days. So initial material present at the time t equal to 0, I can take it as 100 because it is given in terms of percent. So I will take the initial material when t equal to 0, u equal to 100. So this will help you to find out the value of c because So 100 equal to c into e to the power minus k into time t is 0. Therefore, e power 0 it is nothing but 1. This gives you c equal to 100. The constant c is always determined at the initial condition, that is when time t equal to 0. I have taken here u equal to 100 because the data is in terms of percent, so it is taken initially, let it be 100. Then later after 10 days 30% of the material disappears. Therefore, how much is remaining now? So when time t equal to 10 days, u equal to 70. That is because 30% disappears. Therefore, the remaining amount of material is u equal to 70 after 10 days. Now, this condition will help you to find out the value of k. So, that is when u equal to 70, t equal to 10. Let us substitute that here in this equation. We will get, so u is 70 equal to c is 100 into e to the power minus k time t is 10 days. So this is 10. I will get e to the power 1 by e to the power 10k equal to, I'll write it as 1 by e power 10k, 70 by 100. So this is equal to 7 by 10 because one of the 0 cancels. Now cross multiply. So 10 equal to 7 into e to the power 10k. So e to the power 10k equal to 10 by 7. Take log on both sides. 10k equal to log of 10 by 7, natural logarithm. K equal to 1 by 10 into log of 10 by 7. So this is the value of k. I got the value of c and I got the value of k. Substitute back into this equation. So we will get u equal to 100 into e to the power minus 1 by 10 log of 10 by 7 into t. Now find how long will it take for 90% of the material to disappear. When 90% of the material disappears, out of 100, how much remains? So u equal to 10. So t equal to how much? How long will it take? That is asked. So u equal to 10 because out of 100, 90 disappears. 100 minus 90 gives you 10 equal to 100 into e to the power minus 1 by 10 into log of 10 by 7 into time. We have to find out t. So 10 by 100 gives you 1 by 10 equal to, I'll write it as a reciprocal, 1 by e to the power 1 by 10 into log of 10 by 7 into t. Cross multiply. After cross multiplying, you will get it as, I'll write here, e to the power 1 by 10 into log of 10 by 7 into t equal to 10. So take log on both sides. So you will get 1 by 10 into log of 10 by 7 into t equal to log 10, because here exponential log cancels, here just log 10 remains. So t equal to, I'll get t equal to, so this goes to a numerator, that is 10 into log of 10 divided by, this comes to the denominator, log of 10 by 7. So the value of 10 into log of 10 equal to 23.026 divided by log of 10 by 7, approximately it gives you 0.3567. Hence, after simplification, you can do this using scientific calculator or the logarithmic table. So finally, the answer would be t equal to 65 days. Therefore, after 65 days, 90% of the material will disappear. So it takes 65 days to disappear 90% of the material. This is how we solve the problem of decay using the concept of first order linear differential equation. Now, here is a problem. In a certain culture of bacteria, the rate at which bacteria increase is proportional to the instantaneous number present. Instantaneous number present means the number of bacteria present at that time. If the original number doubles in 1 hour, in how many hours will it triple? This is the question. This question is regarding growth. Therefore, so du by dt is directly proportional to u, because the rate at which bacteria increase is proportional to the number of bacteria present at that particular time. As it is growth, so du by dt is equal to k into u, because that constant is positive. Now it is growth. Therefore, solution of this u is c into e to the power kt. This is by the separation of variables method. This I have already explained how you will get u equal to c into e to the power kt. Now first you have to find out the constants c and k using the initial condition. So let us see the conditions, initial conditions. Now, when t equal to 0, when time t is 0 initially, let me take the number of bacteria present as u naught, u equal to u naught. Therefore, u naught equal to, substitute here, c into e to the power k into time t is 0. So this gives you c equal to e power 0 is 1, c equal to u naught. This is the value of c using this initial condition. Now, what is given here? If the original number doubles in 1 hour, when t equal to 1 hour, so what is the number of bacteria present? Original number doubles in 1 hour. So, number of bacteria is 2 into u naught. Initially, it was u naught. After 1 hour, the number of bacteria is in the culture is 2 times u naught. So, this will tell you the value of the constant k. So let us substitute in this equation. So 2u naught equal to c value is u naught into e to the power k, I don't know, time t is 1 hour. So this gives you u naught cancels, power k equal to 2. So k equal to you can find out as log 2, or else directly you can substitute e power k as 2 in the equation. Therefore, your new equation with the value of this c and k becomes u equal to c is u naught into e power k. E power k is 2 I got. Even if you write it as log 2, exponential log cancels. So again you will get 2 itself. So 2 to the power t, because you can write it as a power mn, you can write it as a to the power m whole power n. So e power k is 2, 2 to the power t. So I got the same equation in terms of the values of constants as u naught and 2. So u naught into 2 to the power t. Now what is asked, in how many hours will it triple? So that is, in how many hours? T equal to how much? U equal to 3 times u naught. It will triple. Therefore, substitute in this equation 3u naught equal to u naught into 2 to the power time t I have to find out. So this gives you 2 to the power t equal to 3u naught divided by u naught, which cancels, that will give you 3. So we will get, take log on both sides, log to the base 2 you have to take. So t equal to log of 3 to the base 2. This can be written as log of 3 divided by log of 2, changing the base to the natural logarithm. So hence we will get t equal to, so log 3 to the base e, the value is 1.0986 divided by this value is 0.6931, which is approximately equal to 1.6. Therefore, after 1.6 hours, the original number of bacteria will triple. I hope you understood the concept. Thank you for watching.